Okay, section 9.4 in trigonometry here. Division and the remainder theorem. I thought we'd start out with a division question. Go ahead and read the lowest line left to right, and we'll check your division, because division is important. Okay, so find the line that you need, and then read it as best you can, and then we'll see if you're right. So I'll take a listen here and see what you come up with. Okay, why aren't you talking? All right, okay. Some people are concerned about these things, and other people can't play along, huh? Okay, so example 1, talking about division. Oh, the good old long division. My goodness. I know this is kind of painful for many of you, but it actually isn't too bad. Before I get to this example, I want to refresh your skills on some elementary school stuff. Yeah. 13 and goes into 287. Well, first of all, 13 goes into 28 twice, right? So basically, you're taking 28 and dividing by 13. And all you went in twice, right? So 2 times 13 is 26. And then my big question to you is, did you multiply times the 3? Did you multiply times the 10? Or did you multiply times both of them? Yes, of course, the answer is you multiplied times both of them. That's how we got 26. When you subtract them, or as I like to say, add the opposite. So adding the opposite gives me 2. You'll understand why I say adding the opposite later, okay? Because I see kids make fewer mistakes if they add the opposite. We carry down the 7, all right? Now we're going to say 13 goes into 27, right? So we're going to 27 divided by 13. It goes in 2 times again. And we multiply 2 times the 10 and 2 times the 3, and we get 26 again. Then we distribute a -1, and then we add. Now, nobody in their right mind is going to say 22R1. That's like what you did in elementary school. We would say something like 22 and 1 over 13. Or if you felt like converting that to a decimal, you could, although 13 is probably not a really nice denominator. But the remainder, so now some people, you could say this. I know not very many people do that. Other people could say this, 20 plus 2 plus 1 over 13. Now, I know that there aren't very many people that write it like that either. The reason I'm writing it like that and separating it is because we are going to have unlike terms that we can't add together, including the remainder. And so we will have a polynomial split up into several pieces, separated by addition or subtraction. Okay, so back to example 1 here. The first thing we need to focus our attention on is 6x squared and 3x. So what is 6x squared divided by 3x? That is 2x. And so that expression is going to go right here, 2x. So now I want to distribute this to both of these things. 2x times 3x is 6x squared, and 2x times -1 is -2x. Make sure you put them in the like columns. We are going to distribute a -1 and add down the columns. So we end up with 15x. A lot of kids end up with 11x right there because they fail to realize that they are subtracting. When you subtract a negative, you end up with a positive, or you end up with addition, and they think that they should have 11x there, and so they mess the whole rest of the problem up because of that. Here I'm going to carry down my -5. Now I'm going to repeat the process. Take the first divided by the first. So 15x divided by 3x. That is 5. So that will go next to the 2x on the top. Now I'm going to multiply 5 times both of these things. 15x minus 5. Distribute the negative 1. Add. We got something that went in evenly with no remainder. When it goes in evenly, then these two things must multiply together to give me that. In other words, you could factor that thing into 3x minus 1 times 2x plus 5. There is no remainder. So a zero remainder means something divides in evenly. Let's try it again. Oh, by the way, the answer to that question, just in case you were wondering, was 2x plus 5. Example 2. You'll notice that there's a missing squared term right here. So when I go to do my long division, I must include the 0 term. Yes, that's important. So I'm going to take the first term, cats in crisis, and I am going to divide it by the first term over here. 5x cubed over x. Now that's going to give me 5x squared. And then I'm going to distribute that to both of those, giving me 5x cubed minus 10x squared, cats in crisis. Distribute the negative 1 and add. When you add, you're going to get rid of those. You're going to be left with 10x squared. Carry down the minus 2x. Now, we're going to take this thing right here and we're going to divide by the, so first divided by first again. So 10x squared over x gives me 10x. Multiply times both of those, giving me 10x squared minus 20x. Distribute the negative 1. And add. Carry down the negative 36. First divided by first. Gives me positive 18, which gives me 18x minus 36. Distribute the negative 1 and add. We end up with 0. My goodness, we ended up with 2 that had a remainder of 0. We got to get something with a remainder here so you can see something like that. So that's going to be equal to 5x squared plus 10x plus 18. Now, as you remember from last year, anything that is divisible by a linear factor, or whenever you are dividing by a linear factor, which is what x minus 2 is, a linear factor with a coefficient of 1, unlike the first example we did, you can use synthetic division. So the first thing we do is we look for the 0 that comes from the factor, which in this case is a 2. Remember something like this? So the 2 would go in the box, and then we'd have our coefficients, 5, 0, negative 2, and negative 36. Now, I kind of separate this last one at the end because I know that's going to be my remainder. So we carry down the 5. Multiply. Whoa, I can't multiply, can I? I am a cat in crisis. Alright, so add. No, that wasn't meant as a slam on you, folks. I just meant that I'm in crisis. Oh, goodness. You people can't understand me. I know most of you are looking at me like, what in the heck is he talking about? Alright, so 2 times 10 is 20. We add those together. 2 times 18 is 36, and we add those together. See, every time we're just putting that one in the next column and adding. So that's my remainder, that's my constant, that's my linear term, and that's my quadratic term. And so there's my answer. Yes, most of you love synthetic division compared to long division, but you need to know how to do both. Now, this one right here, you can't do synthetic division with. You must do long division with. So we have x squared minus 2. X, man, that's a bad looking x, to the 4th power minus 8x cubed. Watch out, 0x squared plus 0x plus 12. I had 2 missing terms I had to include. Stuff's getting kind of tricky. So first divided by first, we got 2x to the 4th over x squared. That would give me 2x squared. Multiply times both of these things. 2x to the 4th. 2x squared times negative 2 gives me negative 4x squared. Oh, look, I have to move all the way over and skip the cubic column because it's not a like term. Uh-oh. Wow, that's kind of different. So let's see here. Distribute the negative 1 and add. Don't forget to add this one. And carry down the 0x. Now we take first. So let's see here. We need to divide these two. The first here, negative 8x cubed over x squared. Negative 8x cubed over x squared. That gives me negative 8x. Negative 8x times these two will give me negative 8x to the 3rd plus 16x. Got to skip over to the correct column. Distribute the negative 1 and add. That's going to give me 4x squared minus 16x. Carry down the 12. Alright, now I'm going to concentrate on my first. First divided by first. It's 4x squared over x squared. That reduces to positive 4. Multiply, I get 4x squared. 4 times negative 2 is negative 8. Got to put it in the correct column. Distribute the negative 1 and add, and you get negative 16x and a positive 20. Now, that is a remainder right there. So, what did I end up with? I ended up with 2x squared minus 8x plus 4. Now, here's how I want to show you how to write your remainders. Just like we had that example a few minutes ago where it was like 22 and 1 over 13. And I wrote it out like 20 plus 2 plus 1 over 13. That's what we're going to be doing here. You could see that I have terms that are separated by addition or subtraction. And then at the very end, I'm going to take my remainder and divide by what we were dividing the whole thing by. That's the same idea as the 1 being the remainder and the 13 being what we were dividing by before in that simple example at the beginning. But that's how we want to leave our remainders, okay? Is take the remainder divided by what we were dividing the whole expression in the numerator by. Okay, so when I can do synthetic division, I will be doing synthetic division. So we need to talk about the remainder theorem. Example 4. Find the remainder when 7x to the 5th minus x cubed plus 1 is divided by x minus 2. Well, we could do long division. I don't want to do long division right now. We could do synthetic division, which is a good way to check it, but I'll show you the remainder theorem here. And I will probably check it with synthetic. Okay, so what is the 0 that comes out of x minus 2? Wouldn't that be x equals 2? If you don't remember that, remember, set your factor equal to 0 and solve it, and that's what you'll come up with. So, the remainder theorem says, take this number, plug it into what you're dividing, and you'll come up with the remainder. So 7 times 2 to the 5th minus 2 to the 3rd plus 1. So we have 7 times 32 minus 8 plus 1. 217. Whoops. 217. Now, just to double check that remainder, let's do our synthetic division, right? 2 goes in the box. Our coefficients for this are 7 for the x to the 5th power, 0 for the x to the 4th power, negative 1 for the x cubed power, 0 for the x squared, 0 for the x, and 1 for the constant. Got to make sure you have the right number of zeros in places. So I carry down the 7 and I multiply. And then I add. And then I multiply. And I add. And I multiply. And I add. And I multiply. And I add. And I multiply. And I add. It worked. Do not think you're going to get away without learning the remainder theorem. Those of you who think you can not show me the work when you should be doing the remainder theorem and taking the 0 and plugging it into what you're dividing to find your remainder, if you're not going to show me this work, you're not going to get the credit. I don't care if you think that I'm so foolish as to not see the fact that you did synthetic division and then try to erase it, which some of you try to do. We know who you are. You can use synthetic division to check, but that is not what's going to get you the credit. See you in class. That's a crisis.